Hello everybody and welcome back to Business Statistics Online at Frederick Community College. In this video I will show you how to use Excel functions to compute probabilities for Poisson random variables. So just like with binomial, I assume you read a little bit about this concept and you know what the properties of Poisson random variables are and how to recognize them. So here we will focus on the computational part, and I will solve one straightforward problem where we just talk about notation and computation, and then we'll look at an application problem. So the first problem is from section 5.3, and you will have something similar on your homework, maybe with just different values. So we have a Poisson probability distribution with lambda equal to 2.6, and we're asked to compute three probabilities. So the first one is that x is equal to 5. Okay, we're going to say this is Poisson distribution 5. The mean is, let's see, what was the mean? 2.6. And for cumulative, we're going to say false or 0. Okay, because we want to know the probability of the random variable x being exactly 5. Okay, so value, mean, cumulative or not. Press enter and we get 0.0735. Okay, let's go ahead and input that, 0.0735. Okay, we're good so far. The next probability is asking us what? Let's see. Probability that x is greater than 6. Okay, probability that x is greater than 6. Okay, now our function, just like with binomial, cannot compute probability of x is greater than or greater than or equal to. Here we need to use the complement rule and say this is equal to 1 minus probability of the complement event, which is x is less than or equal to 6. This is your notation. Okay, so if x takes values greater than 6, then the complement of that is less than or equal to, and that probability we can compute. So here we're going to say 1 minus Poisson distribution. We go up to 6 with the mean 2.7, right? Nope, 2.6. And here we will say yes or 1 for cumulative. Okay, so basically we're adding up all probabilities of x is equal to 0, 1, 2, 3, 4, 5, and 6, and subtracting that from 1. Okay, so we get 0, 1, 7, 2. 0.0172. Looks good. And then the last one is less than or equal to 3. Okay, less than or equal to, or at most, right? This is equivalent to saying at most 3. That one we can compute with Poisson distribution. Okay, we'll go up to 3. Mean is 2.6, and here we say yes, true for cumulative, 0.736. Okay, 0.736. All right, that's everything. Okay, so probability, let's go back. Can we go back? Yeah. Okay, probability of x taking exactly the specified value, greater than, less than or equal to. Okay, that's all of the cases that we can cover. So now I would like to take a look at problem 5, I believe. Yes, let's take a look at this problem here. Okay, we have the quality control manager of Maryland's Cookies is inspecting a batch of chocolate chip cookies that has just been baked. If the production process is in control, the mean number of chip parts per cookie is 6.3. Complete the parts A through C. So what is the probability that in any particular cookie being inspected, less than 5 chip parts will be found? Okay, less than 5. Okay, so let me write out here. Probability that X, which is the number of chocolate chips in the cookie, less than 5, right? Okay, so that's your notation. This is equivalent to probability of X is less than or equal to 4, right? This is a discrete random variable, so there are gaps between these values. Okay, less than 5, that's 0, 1, 2, 3, or 4. Okay, to compute this probability, we go Poisson distribution. Okay, we'll go up to 4. Mean 6.3. And cumulative, yes, that's what less than 5 means. Okay, so 2469. Okay, let's see if that's correct. Point 2469. Okay, so far so good. Let's see what the next problem is. What is the probability that in any particular cookie being inspected, exactly 5 chip parts will be found? Exactly 5. We've done this before. This is X is equal to 5. Okay, that's Poisson distribution. X is 5. Mean is 6.3. Cumulative, no. 0 for cumulative. Alright, so this would be, okay, probability is 0.1519, right? We're rounding to 4 decimal places. Let's check the answer. It's good so far. And what about the last one? What is the probability that in any particular cookie being inspected, 5 or more chip parts will be found? 5 or more. 5 or more. What does that mean? Okay. That's probability that X is greater than or equal to 5. What is the probability of that event happening? Greater than or equal to 5. The complement of that is less than or equal to 4. And we have already computed that. So this is 1 minus this event, this probability. Okay? So again, let's talk this through. Greater than or equal to 5. We cannot compute this directly. Okay? Because there's potentially infinitely many trials. Right? So we can't do that for Poisson, which means what? We gotta do the complement. But what is the complement of X is greater than or equal to 5? It is X is less than or equal to 4, which we already know. Okay? So now this is probability of this event 0.7531. And we are done. Okay? So these are the functions that you should be using in computation of probabilities for Poisson random variable. Thank you for watching.